Hey guys, hope you're well. Yeah, so today we're going to look at linear algebra, and we're going to specifically look at solving a system of equations, looking at different methods of doing that. Okay, cool. So on a side note, guys, yeah, I'd really appreciate it if you do subscribe to my channel. So please do subscribe and please share the videos with your friends. So thanking in advance. Okay, cool. So let's get started. So from, and then SymPy, import, and then star. So that's importing the library that I need to use. Okay, then init printing. Okay, and then my symbols X, Y, and Z. So I've got to define them. So symbols X, Y, and Z. Cool. Right. So I've got my system of equations. So equations. Well, let me say EQS. Okay. So 3 times X. Okay, and plus 2y. 2 times y. Yeah. Okay, and minus z. Okay, so that's going to be equal to 4. But what I'll do is I'll just put minus 4 here. Okay, and then write the next equation. So 2x, 2 times x, minus y. Okay, and plus 2z, 2 times z. That's equal to 10. So I'll put minus 10. And then the next one, that'll be x minus 3 times y. Sorry, 3 times y. Okay, and minus 4 times z, which is equal to 5. So I'll put minus 5. Right. So what happens is these numbers, they'll be put onto the other side, to the right hand side. So they'll become 4, 10, and 5. Okay, cool. Right. So cracking on. So AB is equal to so linear, right, equation to, okay, to matrix. Okay, and so I've got my equations there. So EQS, okay, and X, Y, and then Z. Yep. Okay, so my A, so that's my A there, and my B, that's my B there. Okay, right, and then solving for the values for the unknown values x, y, z. So a dot solve b. Okay, actually I'll call it this. Do it this way. Solution. Yeah, S1. Yeah, that will do. Right. So S1. So those are my solutions. Okay. Then I can also do it this way. Solve as well, and that'll be using the LU decomposition way. So A dot LU solve B. So my solution as well. So it's the same thing again. Then I can also do it linsolve way as well. So SOLN, sorry. So linsolve. So AB. And then, sorry, then X, Y, Z. So I'll get my solution set. So solution. So there's my solution set. Okay, cool. Then I can do raw elementary operations as well. So I'll just call it M. Also M equals so my matrix A, yeah, dot raw join B. Okay. So this is M. Okay. Then I'll do the row reduction. So M dot row reduced echelon form. Okay, so these are my solutions. Okay, so that's the identity matrix, and those are my solutions. Okay, okay, let's do it another way. So just finding the inverse and all that. So AI, so that'll be A dot row, and then join the I3, also AI. So that's the matrix, and then the identity matrix. Okay, and then so finding the inverse of that, AI dot RREF. So the identity matrix, that's the inverse of a matrix A. Okay, so it's the same. So A dot inv. Yeah, so there we are, right? And then what I can do is now I can multiply the inverse of A times B to get the solutions as well. So A dot inv times B. There we are. So those are the solutions. And then to find out everything is true, okay? So B dot equals A dot, sorry, A times solution. Or solve. Yeah, that will do. Yeah, which is true. Okay, so it's just a quick way of showing you how to solve a system of equations using different methods in linear algebra. Okay, cool. So if you like what you see, please do subscribe, guys. So please do subscribe. Yeah, thanks for watching again. Bye. Cheers, bye.